In 1941, the United States expected to fight the Second World War with aircraft, tanks, ships, and artillery. Few understood that victory would also depend on something far less visible. Behind the headlines of battles and generals, America faced a quiet but dangerous problem. The nation's factories were ready, its workforce was massive, and its industrial power was unmatched. Yet the raw materials needed to fuel that power were under severe strain. Steel, the backbone of every weapon and vehicle, was becoming increasingly difficult to supply at the speed the war demanded. After the attack on Pearl Harbor, production demands exploded almost overnight. Shipyards needed steel faster than mines could deliver ore. Aircraft factories required aluminum and high-grade alloys in quantities never seen before. Military planners worried that delays in material supply would slow production and, in turn, cost lives overseas. Inside Washington, officials studied charts that showed a troubling gap between what the war required and what the ground could provide. The United States was rich in resources, but time was something it did not have. Amid this pressure, the solution did not come from a battlefield commander or a political leader. It came from an engineer working within America's industrial system. Trained to eliminate waste and improve efficiency, he viewed the problem differently. While others focused on expanding mines and factories, he looked at what already existed. Across the country, millions of tons of metal were being discarded every year. Broken machinery, worn tools, damaged rail parts, and household metals sat unused, slowly rusting away. To most Americans, this material was worthless. To the engineer, it was a hidden reserve. He understood that scrap metal could be melted down and reused far faster than raw ore could be mined, transported, and processed. Scrap required less energy, less time, and fewer logistical steps. In a war defined by speed and scale, those differences mattered. The engineer began studying production records and steel output data. His calculations revealed a simple truth. If scrap metal could be collected and processed on a national scale, it could significantly ease the strain on American steel production. At first, the idea faced resistance. Many industrial leaders doubted that recycled steel could meet the strict standards required for military equipment. Others believed scrap collection would never produce enough volume to make a real difference. But the numbers told a different story. The engineers showed that the United States was already surrounded by usable material, scattered across cities, farms, rail yards, and factories. What was missing was coordination. As the war intensified and production deadlines tightened, the engineers' proposal gained attention. Officials within the war production system began to see scrap not as a supplement, but as a solution. The question was no longer whether recycling could help. The question was whether the nation could organize itself quickly enough to turn waste into weapons. What followed would transform the American home front and redefine how industrial wars were fought. Victory, it turned out, would not be forged only from newly mined steel. It would also be built from what the nation had once thrown away. In the days following Pearl Harbor, the United States entered the war with urgency, fear, and determination. Military planners knew the nation would have to fight on multiple fronts, across oceans, against enemies that had been preparing for years. What became clear almost immediately was that this would not be a short war. It would be a war of endurance, scale, and industrial power. Weapons had to be produced faster than ever before, and in numbers that dwarfed anything the world had seen. Behind closed doors, officials worried that America's greatest strength could also become its greatest weakness. The problem was not factory space or labor. America had both in abundance. The real crisis was materials. Steel production was stretched thin as shipyards demanded plate steel for hulls, armor steel for tanks, and high-grade alloys for aircraft engines and weapons. Copper was needed for wiring and ammunition. Aluminum was critical for aircraft frames. Rubber shortages threatened tire and vehicle production. Each material depended on long supply chains that could not expand instantly. Mines could not simply dig faster. Railroads were already overloaded. Ports were crowded with military cargo. The War Production Board, created to coordinate this massive effort, was flooded with reports of bottlenecks and delays. Factory managers warned that assembly lines would slow or stop without guaranteed material flow. Shipyards reported waiting weeks for steel deliveries. Aircraft manufacturers competed for the same limited resources. Every delay on paper represented planes that would not fly and ships that would not sail. The pressure was constant, and the stakes were deadly serious. Germany and Japan understood the importance of production. Both had reorganized their economies for war years earlier. If the United States failed to match or exceed their output, its military advantage would evaporate. American leaders feared a scenario where soldiers were trained and ready, but lacked the equipment they needed to fight. This was not a theoretical concern. Early war production schedules showed alarming gaps between demand and supply, especially for steel. The crisis forced officials to rethink traditional assumptions. The idea that raw materials must always come from mines and new sources began to feel outdated. Expanding mining operations required time, labor, and infrastructure, all of which were already under strain. Transportation networks were stretched to their limits. The war demanded faster solutions, not perfect ones. Efficiency became more important than tradition. Within the War Production Board, debates grew intense. Some argued for rationing civilian use more aggressively. Others pushed for stricter controls on industry. Yet none of these measures created new steel. They only redistributed scarcity. What the system needed was additional supply that could be mobilized immediately. This sense of urgency created an opening for ideas that might have been dismissed in peacetime. It was in this environment of pressure and uncertainty that scrap metal began to look less like waste and more like opportunity. What had once been considered a marginal resource now appeared as a possible answer to a growing crisis. The material shortage was no longer an abstract problem. It was a ticking clock, and every day that passed brought the war closer to American factories and American lives. He was not a general, and he did not wear a uniform. He did not command troops or plan invasions. His battlefield was paper, numbers, and factory floors. The engineer had spent his career studying how systems failed and how waste slowed production. Before the war, his work focused on efficiency, cost reduction, and industrial flow. When the United States entered the conflict, those skills suddenly became as valuable as any weapon. Inside the War Production Board's expanding bureaucracy, the engineer stood out because of how he framed problems. While others asked how to produce more steel, he asked why so much usable metal was being ignored. He had seen the data. Scrap rates in American industry were high even before the war. Factories discarded offcuts. Railroads replaced worn components and dumped the old ones. Cities removed outdated infrastructure and sent the metal to landfills. In peacetime, this waste was tolerated. In wartime, it became unacceptable. The engineer believed that production was not just about making more. It was about using what already existed more intelligently. He began compiling reports that compared scrap recovery rates with steel output. The results were striking. Scrap steel required less processing than raw ore. It bypassed mining delays, reduced transportation strain, and entered furnaces faster. In a war where speed mattered as much as volume, scrap offered a critical advantage. His position within the system allowed him access to detailed production records. He studied how long it took for ore to become usable steel and compared it to scrap melting cycles. The difference was measured in weeks. Those weeks could decide whether a ship launched on time or an aircraft squadron received its planes. The engineer did not argue from theory. He argued from measurable results. Convincing others was not easy. Many officials viewed recycling as a civilian concern, not a military solution. Steel executives worried about quality control. Military inspectors feared that recycled materials would compromise equipment reliability. The engineer responded with data, not promises. He showed that properly sorted scrap could meet the same specifications as newly produced steel. He demonstrated that the issue was not material quality, but organization and scale. Gradually, his arguments gained traction. As shortages worsened, skepticism weakened. The War Production Board needed solutions that could be implemented immediately, not years later. The engineers' proposal did not require new mines or massive construction projects. It required coordination, public participation, and clear policy. Most importantly, it required a shift in mindset. For the engineer, the war was not won by one invention or one factory. It was won by systems that eliminated delay and waste. Scrap metal represented both a problem and a solution. Left unused, it was a symbol of inefficiency. Collected and recycled, it became a weapon. By reframing waste as opportunity, the engineer offered the war effort something it desperately needed: time. To many Americans, scrap metal was a sign of neglect or decay. It was what remained after something had outlived its purpose. Old stoves behind houses, broken farm tools leaning against barns, rusted rail parts stacked near depots, and discarded factory machinery were seen as clutter, not resources. Before the war, no one had reason to think otherwise. Raw materials were cheap, and industry preferred new steel over reused metal. The engineer understood that this mindset no longer fit a nation at war. He argued that scrap was not a substitute for real steel. It was real steel. Once melted, refined, and processed, it behaved no differently in a furnace than metal drawn from freshly mined ore. What mattered was sorting and control. If scrap was properly classified and cleaned, it could meet military specifications. The challenge was not technical. It was psychological. Industry had to abandon the belief that new was always better. The engineer's proposal reframed the entire supply chain. Instead of viewing scrap as the end of a product's life, he treated it as the beginning of another. A damaged rail could become armor plate. A broken machine part could become a gun barrel. Household metal could be transformed into ship hulls. This circular view of production was radical for its time, especially on a national scale. Critics pushed back hard. Some steel producers feared contamination and inconsistent quality. Others warned that collecting scrap across such a vast country would be inefficient and chaotic. Military procurement officers worried about accountability. If something failed in combat, recycled materials would be blamed. The engineer did not deny the risks. He acknowledged them and showed how they could be controlled. He proposed standardized sorting systems, regional collection centers, and strict inspection procedures. What made the idea powerful was its speed. Scrap already existed. It did not need to be discovered, mined, or transported from distant regions. It was already close to cities, factories, and rail hubs. In many cases, scrap could be processed and delivered to mills faster than raw materials. For a war that demanded constant acceleration, this advantage could not be ignored. Inside the War Production Board, attitudes began to shift. Officials who once dismissed scrap as marginal started asking how much could be collected, and how quickly. Reports showed that even modest increases in scrap recovery could relieve pressure on critical supply chains. As aircraft orders multiplied and shipbuilding schedules tightened, the idea of leaving usable metal untouched began to seem reckless. The engineer's concept was no longer theoretical. It was becoming a necessity. Scrap was redefined not as waste, but as reserve. Not as leftovers, but as potential. This shift in thinking laid the foundation for one of the largest civilian mobilizations in American history, a mobilization that would soon reach into every neighborhood and every household. The War Production Board could not afford hesitation. By 1942, the scale of the war had erased any room for caution or delay. Ships were being lost faster than they could be replaced. Aircraft production schedules were under constant pressure. Every branch of the military demanded priority access to steel, and no one wanted to be told to wait. Faced with these realities, the board made a critical decision. Scrap metal would no longer be treated as a secondary resource. It would become a pillar of national production policy. Orders were issued that changed how industry operated. Steel mills were instructed to increase their use of scrap in production wherever possible. Guidelines were established for sorting, grading, and transporting recycled metal. The engineer's recommendations were formalized into policy, turning his calculations into enforceable standards. This shift did not happen quietly. It required coordination across multiple agencies, industries, and regions, all operating under intense wartime pressure. To support the policy, the War Production Board reorganized supply priorities. Civilian access to new steel was further restricted, pushing non-essential industries to rely on recycled materials or suspend production entirely. This freed raw materials for military use and increased demand for scrap. The message was clear. If the war was to be won, every available resource had to be brought into the system. The board also understood that industry alone could not supply enough scrap. The scale required went far beyond factory waste. To meet targets, metal would have to come from the public. This marked a turning point in the war effort. The home front was no longer just supporting the war through rationing and labor. It was now directly supplying the raw materials needed to build weapons. National targets were set, and progress was closely tracked. Reports flowed into Washington detailing tonnage collected, processed, and delivered. In some regions, scrap deliveries exceeded expectations. In others, shortages remained. The War Production Board adjusted strategies constantly, refining logistics and addressing bottlenecks as they emerged. This was industrial warfare in its purest form, measured in tons and timelines rather than territory. Resistance did not disappear overnight. Some industries complained about increased costs. Others struggled with quality control. Yet the urgency of the war left little room for debate. The policy was not optional. It was enforced through regulations, inspections, and, when necessary, penalties. The engineer's idea had moved beyond persuasion. It had become doctrine. As scrap metal began flowing more consistently into mills, early results confirmed what the data had predicted. Steel output stabilized. Production delays eased. The system was far from perfect, but it was working. What had once been seen as waste was now a strategic asset, managed at the highest levels of government. This decision set the stage for a massive national effort that would soon involve millions of Americans. The policy was in place. The system was ready. All that remained was to gather the metal itself. Once the policy was set, the war effort moved beyond factories and offices and into American neighborhoods. The War Production Board understood that success depended on scale, and scale required participation. Scrap metal was everywhere, but it was scattered. To collect it in meaningful quantities, the nation itself had to be mobilized. This marked a shift in how civilians experienced the war. They were no longer just observers or supporters. They became suppliers. Across the country, scrap drives were organized with military urgency. Local governments coordinated with schools, churches, unions, and civic groups. Newspapers printed collection schedules. Posters appeared on walls and storefronts urging Americans to search their homes and communities for unused metal. The message was simple and direct. What you give today becomes weapons tomorrow. The appeal was not abstract. It was personal. Every piece of metal was framed as a contribution to a soldier, a sailor, or a pilot overseas. Children played a surprising role in this effort. Schools encouraged students to gather scrap from their neighborhoods. Boys pulled wagons loaded with old pipes and broken tools. Girls collected cookware and metal household items no longer in use. These efforts were celebrated publicly, turning collection into a form of patriotic duty. For many families, donating scrap became a visible way to feel connected to the war. Farmers and industrial workers were also critical contributors. Old farm equipment that could no longer be repaired was hauled away. Railroads released worn components that had been stockpiled for years. Factories increased recovery of internal waste and redirected it into recycling channels. The effort reached into places that had never been part of national campaigns before. Small towns, rural communities, and industrial centers all became collection points in a growing network. The logistics were complex and often chaotic. Scrap had to be sorted, transported, and delivered without disrupting other critical supply chains. Rail lines already crowded with military cargo now carried loads of recycled metal. Temporary storage yards appeared near mills and rail hubs. Despite these challenges, the system held. Month after month, reported scrap tonnage increased. What made the effort remarkable was its speed. Within a short time, millions of tons of metal were pulled into the production system. This was not a slow cultural shift. It was a rapid transformation driven by necessity and reinforced by constant messaging. Americans were reminded that waste was no longer acceptable. In a total war, unused resources were liabilities. For many participants, the full impact of their contributions was invisible. They did not see ships being built or tanks rolling off assembly lines. Yet the connection was real. Recycled metal flowed directly into mills, where it was melted, refined, and shaped into components for war. The scrap drives closed the gap between civilian life and industrial combat power. This mobilization did more than supply material. It created a shared sense of responsibility. The war was no longer distant. It was present in garages, kitchens, and schoolyards. By turning ordinary citizens into suppliers, the United States unlocked a reserve of strength that had been hiding in plain sight. By late 1942 and into 1943, the results of the scrap mobilization began to appear clearly in production reports. Steel mills that had once struggled with irregular supply now operated with greater consistency. Furnaces ran longer and more efficiently as scrap became a steady input rather than an occasional supplement. What had started as an emergency measure was becoming a reliable system. Scrap was no longer filling gaps. It was driving output. Recycled steel moved quickly from collection yards into mills and then into factories. The time saved by bypassing mining and long-distance transport added up. Shipyards reported fewer delays caused by material shortages. Aircraft plants received more predictable deliveries of steel and alloys. Tank factories increased output as armor plate became more available. The flow of material stabilized assembly lines that had once been at risk of slowing or stopping entirely. The scale of production was unprecedented. Liberty ships, designed for rapid construction, benefited directly from increased steel availability. Shipyards launched vessels at a pace that stunned both allies and enemies. Each ship represented not only industrial efficiency, but the success of a system that turned civilian scrap into strategic assets. What had been collected from backyards and farms now crossed oceans carrying troops, fuel, and equipment. The impact extended beyond ships. Artillery pieces, vehicles, and ammunition all depended on steel. Recycled metal found its way into gun barrels, vehicle frames, and support equipment. While no single piece of scrap could be traced to a specific weapon, the cumulative effect was undeniable. Production targets were met more consistently. Delays that once threatened operations were reduced. This period marked a turning point in the industrial war. American output surged, and the gap between demand and supply narrowed. The fear that material shortages would cripple production began to fade. Reports to Washington reflected growing confidence. The system was working under pressure, adapting as demands increased. Scrap metal, once dismissed as marginal, had become essential. The engineers' calculations were now reflected in real-world results. Faster steel production meant faster deployment. Ships reached the Atlantic and Pacific in greater numbers. Equipment arrived overseas in time to support expanding operations. The link between scrap drives at home and combat readiness abroad, though indirect, was real and measurable. The success of recycling at scale also sent a message to American industry. Efficiency and flexibility could overcome constraints that once seemed insurmountable. The war was not being won by one breakthrough, but by thousands of interconnected decisions that removed waste from the system. As production surged, the United States crossed a critical threshold. It was no longer struggling to keep up. It was beginning to overwhelm its enemies through sheer output. Scrap metal, melted and reshaped, had become part of the steel backbone of American power. As American production accelerated, the difference became visible in the numbers. By 1943, the United States was producing more steel, ships, and aircraft than any nation in history. This was not a gradual advantage. It was a dramatic shift that reshaped the balance of the war. While Germany and Japan struggled with limited resources and damaged infrastructure, American factories expanded output month after month. The flow of materials no longer matched the enemy. It overwhelmed them. Steel production formed the foundation of this surge. With scrap fully integrated into the system, mills operated at levels that would have been impossible earlier in the war. The steady supply allowed manufacturers to plan ahead rather than react to shortages. This stability mattered as much as volume. Predictable production meant faster assembly, fewer delays, and more reliable delivery schedules for the military. The impact was most visible at sea. American shipyards launched vessels faster than German submarines could sink them. Liberty ships and later Victory ships poured into the Atlantic and Pacific. Each launch reduced the threat posed by enemy blockades. Supply lines that once seemed fragile became resilient. Troops, fuel, and equipment reached distant fronts in increasing quantities, shifting the strategic balance. On land, the effect was equally significant. Tank production soared. Vehicles and artillery reached units faster than before. The United States could equip not only its own forces, but also those of its allies. This ability to supply multiple armies at once placed immense pressure on Axis resources. Germany, in particular, struggled to match the pace, especially as Allied bombing disrupted its industrial base. Aircraft production told a similar story. Planes were built, repaired, and replaced at a speed that allowed American air power to expand continuously. Losses could be absorbed. New squadrons could be formed. This flexibility gave commanders options that their enemies lacked. Industrial strength became operational freedom. These numbers were not abstract statistics. They translated directly into battlefield advantage. More ships meant secure supply routes. More vehicles meant faster movement. More aircraft meant sustained air superiority. The enemy faced a growing reality. Even when they won battles, they could not win the production war. Scrap metal did not act alone, but it played a crucial role in sustaining this output. It reduced strain on mines, shortened production cycles, and allowed the system to scale rapidly. By eliminating waste and maximizing available resources, the United States turned efficiency into a weapon. By the midpoint of the war, the outcome was no longer determined solely by tactics or courage. It was shaped by the ability to produce, replace, and reinforce at a level the enemy could not match. The industrial gap widened with each passing month. What began as a material crisis ended as an industrial advantage that proved impossible to overcome. When the war reached its later stages, the engineer's work faded quietly into the background. There were no parades in his name, and no headlines celebrating his contribution. He remained largely unknown to the public, even as the system he helped shape continued to deliver steel at unprecedented levels. This was fitting in a way. His achievement was not a single invention or dramatic breakthrough. It was a structure, a method, a way of thinking that removed waste and replaced it with momentum. Inside government records and production reports, his influence was clear. Scrap recovery targets became standard planning figures. Recycling processes were refined and improved as the war progressed. What began as an emergency solution evolved into a disciplined system embedded in American industry. Steel producers no longer saw scrap as a compromise. They saw it as an asset. The engineers' insistence on data, standards, and coordination had changed how decisions were made. As victory came into sight, attention shifted toward the future. Factories prepared to transition back to civilian production. Mines reopened at normal pace. Yet the lessons of the war did not disappear. Industries that had once resisted recycled materials now understood their value. Post-war manufacturing adopted many of the same efficiency principles developed under wartime pressure. Scrap recycling remained part of industrial planning, long after rationing ended. The engineer himself returned to a quieter role. His work continued in advisory positions and industrial consulting, far from public attention. He did not seek recognition. His success was measured in output graphs, not medals. What mattered to him was that the system had held when it was needed most. It had delivered under pressure. It had saved time when time was the most valuable resource of all. His legacy extended beyond steel. It demonstrated that wars are not won only by bravery or strategy, but by organization and foresight. It showed that solving large problems often requires rethinking what is already available, rather than searching for something new. The engineer proved that efficiency could shape history as decisively as force. By the time the war ended, America's industrial identity had changed. The nation had learned how to mobilize not just factories, but people and materials on a massive scale. Scrap metal, once ignored, became a symbol of that transformation. It represented the power of collective effort guided by careful planning. The engineer never became a household name. Yet his work lived on in every ship launched on time, every vehicle delivered when needed, and every delay that never happened. His contribution was quiet, but it was permanent. When the war finally came to an end, victory was measured in territories liberated and enemies defeated. Yet behind those visible achievements lay an industrial story that rarely made headlines. The United States did not win the war by chance or by strength alone. It won by learning how to use everything it had, including what it once ignored. Scrap metal, pulled from homes, farms, and factories, became part of the foundation of American power. What made this transformation remarkable was not just the volume of material collected, but the speed and coordination with which it was done. In a moment of crisis, the nation learned to see waste as potential. Ordinary citizens became contributors to industrial production. Engineers became strategists. Factories became instruments of national survival. The line between civilian life and the battlefield blurred, not through violence, but through logistics. The story of scrap recycling during the war challenges how victory is usually understood. It reminds us that battles are often decided long before soldiers arrive at the front. They are decided in planning rooms, in production schedules, and in systems that prevent failure before it occurs. Steel forged from recycled metal did not carry a label into combat, but it carried weight all the same. It held ships together. It armored vehicles. It sustained the momentum that pushed the war forward. This effort also revealed a deeper truth about modern warfare. Power does not come only from weapons, but from the ability to sustain them. The engineer who helped turn scrap into steel understood this better than most. He recognized that time, efficiency, and coordination could decide outcomes on a global scale. His work showed that innovation does not always require invention. Sometimes, it requires attention. Long after the war, the lessons remained. Recycling, once seen as a wartime necessity, became a permanent part of industrial thinking. The idea that waste could be reclaimed and reused shaped future production methods. What was born under pressure became standard practice. The steel that helped win the war did not all come from deep mines or distant sources. Much of it came from what Americans were willing to give up. Broken tools, outdated machines, and discarded household items were transformed into instruments of victory. In that transformation lies the real story. The war was not only fought with fire and force. It was won with foresight, organization, and the courage to rethink what mattered. Sometimes, the strongest weapons are not newly made. They are already there, waiting to be used.